Hi guys, welcome back again. Mr. Donnelly here. Last time we left off, we talked about balancing chemical equations, and we're moving on to the next logical step here, which is talking about the mole, so we can see what's really going on with those chemical formulas we learned how to write and those chemical equations we learned how to balance. The mole is a unit of measure from chemistry, and it's one that's used to measure really large numbers in a very simple fashion. So if you took a look over on the board here, I have three words written. Well, actually more than that, but look at the first three. I have 1 mole, 6.022 times 10 to the 23rd, and the words Avogadro's number. All three of these things have one thing in common. The thing in common is they're all exactly the same, which is good for us because we can actually do some calculations in chemistry in a very simple fashion for numbers that are really big. A little bit of background information about the mole first. So that number 6.022 times 10 to the 23rd is the mole, and it is Avogadro's number. That being said, if I tell you I have 1 mole of elephants, you would tell me I have 6.022 times 10 to the 23rd elephants. If I told you I had 1 mole of sodium atoms, you would say I have 6.022 times 10 to the 23rd sodium atoms. And if I said that I had 6.022 times 10 to the 23rd molecules of oxygen, you would tell me I had 1 mole of oxygen. So the numbers are the same. 1 mole is 6.022 times 10 to the 23rd atoms or molecules in chemistry. In the world, it could be literally anything. So, with that out of the way, let's take a look at the first step in learning how to deal with a mole. So, from here on out, whenever I say 1 mole or molar mass, in your minds, you need to remember that I'm talking about 6.022 times 10 to the 23rd atoms or molecules of an element or a compound. So, let's get started. I'm going to try to keep this as quick as possible. This is not the most difficult lesson ever. So, we're talking about the mole. We introduced the concept of the mole. We should understand that the mole is represented in 3 different ways. Now, we're going to look at what molar mass is and how to use molar mass to calculate the number of moles in a given quantity of a substance. Okay? So let's look at the molar mass. So I'm going to take this abbreviation for the mole, and now we're going to talk about molar mass. So molar mass is the mass of 1 mole of a nonmetal element or covalent compound. That's molar mass. Formula mass is very similar. The difference between molar mass and formula mass is that formula mass is for metal elements and ionic compounds. Okay? So the calculations for both will be the same. What's different here is the terms. So we calculate formula mass for the ionics and the metals, molar mass for the nonmetals and covalents. So I'll write that on the board also. So formula mass is the mass of 1 mole of a metal or ionic compound. Pretty straightforward. Fortunately for us, calculating molar mass and formula mass is pretty darn easy, as long as you know how to use your periodic table and a calculator. So, from here on out, we're going to be calculating molar mass. When we calculate the mass of 1 mole, we're also saying that there's 6.022 times 10 to the 23rd atoms or molecules inside of that 1 mole of mass that we calculated. Hopefully you're hanging with me here and you're not confused yet. Hopefully not at all. So going forward here, I'm going to erase what I have on the board. Hopefully you filled in the notes, fill in the blanks that I gave for you. And we're going to take a look at how to calculate, first, how to calculate molar mass. Then we'll look at how to calculate formula mass. So a rule that we have to follow when calculating formula mass, when calculating molar mass, is to use our periodic table. So let's take a look at molar mass calculations here. We have my periodic table flying away. So molar mass calculations. Molar mass calculations. Let's start with an easy one. Let's start with carbon. Carbon, as you guys know, is element C, or number 6 on the periodic table. To find the molar mass of carbon, what do I have to do? I just look for its atomic mass. Its atomic mass, carbon's atomic mass, is 12.011. I'm going to round that to 12.01. So carbon equal 12.01 grams. So molar mass equal 12.01 grams. So 1 mole C equal 12.01 grams. Now, all that stuff that I wrote down right there is a lot. What I'm telling you is that if I have 1 mole of carbon, I have 12.01 grams of carbon. That equates to 6.022 times 10 to the 23rd atoms of carbon. So if you actually went over to the scales in the back and you measured 12.01 grams of carbon onto a scale, and then you took several 100,000 lifetimes to count those atoms that you put on the scale, you would count 6.022 times 10 to the 23rd atoms of carbon. That's the molar mass of carbon. Pretty straightforward. What about formula mass? Well, you do formula mass exactly the same way. So formula mass for elements. So formula mass calculation for elements. Notice I haven't talked about compounds yet. Let's take iron. So iron is number 26 on the periodic table. It's got a formula mass of 55.84. Iron equals 55.84 grams. So what I'm saying is that the molar mass of Fe equals 55.84 grams. And I'm also saying that 1 mole of iron, 1 mole Fe equals 55.84 grams. Pretty easy. Molar mass and formula mass are calculated identically. Difference is that molar masses are calculated for nonmetals and covalent compounds. Ionic compounds, you calculate the formula mass the same way. Or metal elements. Now, these things being said, it does get a little bit more complex. So let's take a look at molar mass for compounds. So calculated molar mass for compounds. This thing's trying to get away from me. So calculate molar mass. Let's do CO2 first. So I have CO2 on the board. It's composed of 1 carbon and 2 oxygens. Let's find the molar mass of carbon first. Carbon, as we said before, is 12.01 grams. Oxygen, 15.99 grams from the periodic table. Oxygen's molar mass is 15. I have 2 oxygens, by the way. 2 oxygens is 15.99 grams. Since I have 2 oxygens, I multiply it by 2. Add these together to find the molar mass of the compound. So I'm going to add them together and get an answer. Here's where you get to use your calculator. So you break out your calculator, you do 15.99 times 2 equals, then add 12.01 grams to it, it equals, and I got 43.99 grams. So 43.99 grams, and of course, I have the correct number of significant figures here, 2 places past the decimal. 43.99 grams equal 1 mole CO2. Pretty easy, right? Pretty straightforward for CO2. Let's do another molar mass for a compound that's a little bit more tricky, okay? Let's try good old ammonium phosphate. So let's take a look at ammonium phosphate. Ammonium phosphate is NH4, 3 PO4. So that's a more complex compound, right? It's polyatomic. I have 3 ammoniums and 1 phosphate. We use the same process here as we used before. So first, let's take a look at nitrogen. Nitrogen has a molar mass of 14 grams. And I have 3 nitrogens. I got 3 nitrogens, each worth 14 grams. So I'll have to take that 14 grams and multiply that by 3. Each one's worth 14 grams, and I have 3 of them. I also have 4 hydrogens inside the parentheses and 3 out. That 3 is distributed to the parentheses. 3 times 4 is 12. That means I have 12 hydrogens. So I have 12 hydrogens. Looking at my periodic table, each hydrogen has a mass of approximately 1 gram, molar mass of 1 gram. So I have 1, I should put a gram sign here, 1 gram sign here, and I have 12 of them, so that's times 12. Then I have my phosphorus. Phosphorus is over here, number 15. I've got 1 of them. So phosphorus, there's just 1. And it weighs 30.97 grams. And I have, lastly, oxygen. I have 4 oxygens. So I have oxygen. Of those, I have 4. So 4 oxygens. That is not a 40, but 4 oxygens at 15.99 grams each. 4 of them. Multiply it by 4. There we go. So now we break out our calculators. Remember to put that plus sign there. So let's do some calculation here. So I got 14 times 3 for the nitrogens. That gives me 42 grams. For the hydrogens, I got 12 times 1. That gives me 12 grams. For the phosphorus, it's 30.97 grams. And lastly, for the oxygen, it's 15.99 times 4. So I got 63.96 grams. 63.96 grams. I'm going to take all these values and add them together. So here I'm going to get 42 plus 12 plus 30.97 plus 63.96. I got 148.93. Now I've only got 2 significant figures for my least amount when I do the addition. I'm going to ignore the significant figures now so as not to confuse you as much and simply put the answer down that I got on the calculator, which is 148.93 grams. 148.93 grams. The molar mass of ammonium phosphate is 148.93 grams. So 1 mole NH4 or ammonium phosphate equals 148.93 grams. So that's the calculations you do to determine molar mass. You do the exact same thing for formula mass. I really don't have to show you how to do the formula mass if you can do the molar mass. Just look at them and be able to determine if you're calculating for formula mass or molar mass because you do the calculations exactly the same way. Last thing I want to talk about. A few minutes ago I had mentioned that when calculating molar mass for elements, all you have to do is look at the periodic table and find its atomic mass. Addendum to that. I forgot about good old Dr. Hofbrinkel. So Dr. Hofbrinkel is a doctor that always recommends that you take two of the following. You always take 2 hydrogens, 2 oxygens, 2 fluorines, 2 bromines, 2 iodines, 2 nitrogens, and 2 chlorines. Well, what does that mean? It means that in nature, you'll never find any of those elements, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, or chlorine, as single entities. They always come in diatomic molecules, or 2 of each. So you'll always find H2, you always find O2, F2, Br2, I2, N2, and lastly Cl2. So you might wonder, Mr. Donnelly, how you find the molar masses of these. Well, it's pretty simple. You find the atomic mass of that element on the periodic table and multiply that value by 2. So hydrogen weighs 1.0 grams times 2. H2 is 2.0 grams for every mole. Guess what? 15.99 times 2. I bet you can figure out what the value for oxygen is. 15.99 times 2 gives me 31.98 grams per mole. 31.98 grams for every mole, etc. for the remainder of those elements. So pretty straightforward for finding or doing calculations for molar mass. Now, if you haven't done so yet, come see me for the worksheet to figure this stuff out and give it a shot. Have a great day.